So now we are going to move on to the next item in the agenda is an open discussion, so which will be modulated by Anat Shahar and then Jin Zhang.
Okay, well, so thank you all for all the great talks so far. One of the things that we want to talk about when it comes to this new organization is what techniques do we already have at Beamlines, and what techniques we want in the future. So I think Stella has a survey for you to do.
Yes, like the previous days, we will kindly ask you to just join the link that was just forwarded in the chat. And there you will find the survey. It has 2 parts. They're very closely related. So basically, we want you to tell us which of the following techniques you have used and which of those you are planning to use in the near future. I remind to everyone the survey is anonymous and it just takes less than a few seconds to do it. So here we have 40 responses so far. Please continue to give your response. And the first question is are the techniques that you have used, and the second one is a result of those that you would like to use in the near future. And I will give it back to Anat and Jin for further discussion.
Thanks, Stella. So you can see a lot of people use X-ray diffraction. And so this is kind of the question we'd like to ask you all is, a lot of times we have X-ray diffraction combined with another technique at the synchrotron. But in the future, when we're thinking about, all the possibilities that we could possibly have, any new online techniques or some new combination of techniques, what would you like to see? What is something that you think would be, really extraordinary that would really help the science?
Frankly said, there are some techniques that I am not even sure what these can be used for. Maybe some experts can explain a little bit more. For example, what coherent scattering can be used for, and also the total X-ray scattering is also sort of like not too many people are mentioning, like they want to use it or they have been using it. But maybe some experts who's more familiar with these techniques can give the audience a little bit more information about these two.
Yeah, total X-ray scattering is basically when you study amorphous material and getting PDF and structure factor. And coherent scattering, it's not available yet everywhere because we don't have much coherence lens at the synchrotrons. But after APS-U, we should have it, and it's quite new techniques, and nobody else is using it at high pressure. So it will be up to community to check it out and discuss if we need to develop. It requires some extensive computation after you collect the data. But the result could be very interesting, like correlation spectroscopy. You can even get viscosity from the molten materials, and you can have an imaging. A few was mentioned here during the workshop that it will be nice to have high resolution imaging of the sample at high pressure and high temperature, and that basically should be possible. But again, it will require not only availability from the X-ray point of view, but also extensive computational and data analysis to reconstruct the image.
So is this technique sort of like coherent scattering going to be available at the current like beamlines, or requires extensive like development technically?
No, I mean, potentially yes. So the IP8 after upgrade, APS-U will have much better coherence length and time. So we can use it start after upgrade, not right now.
Okay.
But yeah, we have to be ready for that. So you basically, as a community, you have to take a look on this technique and see how it's used right now. It's ambient conditions, and we can apply it later. At SRF, they already start quite a bit of using this technique.
Oh, great. Always nice to have new tools.
Yes. For right now, I think it's more important if some of you can tell what the optimal combination of X-ray technique and optical technique you probably want to see at the one beamline.
Absolutely. So I have 2 more slides. Maybe I can show. Can you guys see this question? So the first question we're looking at is what sort of a combination of X-ray techniques, like 2 added together, like in one station. There are all these different kind of techniques listed over here. I put some examples over here that currently we have at some stations, like within one station. Some of them are, can be applied at the same time, but some of them, like, it's in the same hatch, but it's different techniques. For example, like certain BMDs, tomography versus regular X-ray diffraction, versus the DEC, X-ray diffraction, these 2 are probably separated, but the regular, like a powder, maybe can be combined. And the IDD has all different kind of, basically these are all different kind of techniques are combined, but some of them you cannot do it at exactly the same time. But these are some examples of current X-ray techniques we have. There's some wish list that list all over here. That's from the information that Stella shared with me. But what else? So of course, tomography plus X-ray diffraction, endowment cell, endowment inclusions. Endowment inclusions is sort of like from the talks we heard like a couple of days, like 2 days ago, 1 day ago. Like it's already like, it's ongoing and it's shown some really promising result, but is that possible in endowment cell? And for some people also mentioned like with FTIR plus XRD are possible at the beamline. So these are the stuff we're having right now. Maybe you guys have some, more wish list.
I was just going to comment on, not necessarily on the wish list, and I apologize. I heard part of it as somebody walked in my office, but the one thing is a lot of the spectroscopy techniques, at least at HVCAT, they're underused by the community. And of course, COVID doesn't help this. I mean, by any means, people cannot come on site and whatnot, but I don't know if we have exhausted the use of current techniques, and that is my concern, because a lot of the spectroscopy techniques in particular are expensive, to set up and so forth. And a lot of times they seem to be focused on, single scientific, need. And then after that need is met, it's not applicable to other things. So that's just my general concern, not about the techniques. I mean, it's good to have the array, but.
Yeah, definitely. Like the user community, whether there's enough need and what should we focus on.
Yeah. So yeah, I guess my comment or question to the community is what can be done to enhance the use of the current capabilities, and is it software? Is it theory and modeling? Like, would that help if we have more theory and modeling with these? So yeah, more of a question.
Yeah, exactly. So the other sort of like relevant questions, like not only X-rays techniques combined, but also combined with some other like optical development, optical spectroscopy development, like Raman fluorescence, and also other capabilities like ultrasound measurement, conductivity measurement, expand the PT conditions and stuff. I also list a wish list over here. Some I'm not sure are even feasible. For example, the 5,000 tall LVP put it at the beamline, I guess probably would be difficult, I guess. We need a really huge hatch to fit this giant stuff. So it's a giant apparatus. So, oh, there's somebody. Sergey? You can unmute yourself.
I did not want to interrupt you.
Oh, no worries.
I just raised my hand. So let me know when you want me to comment on.
No, sure, go ahead.
Yeah, so one of the things, in my opinion, that is missing, throughout this workshop is the discussion on the non-gray emissivity of many geological materials. So we rely on the gray body assumption all the time, and this is my personal opinion. And I mean, you may agree or you may disagree with me, but I think if we really want to move forward from this assumption, optical techniques are essential to have online, such as just optical probing of a sample, optical absorption, or measuring light scattering in samples. I think these are important. You know, they may be more important for some experiments when you, for example, measure the melting temperature of pyrrolite or whatever, and they perhaps are less important for when you have a metallic sample. So, but I think overall, this is what I would personally like to see as an upgraded GCCARS. I know there is an independent offline system for that, but it would be much more convenient to use something like that as you run your experiment online.
What's the precision you want to see?
What do you mean by that?
Precision in the temperature determinations that will be useful for Earth model.
Yeah, I think this is a very good question. I think we as a community have not been very honest about the uncertainty in temperature determination in laser heated diamond angle cells. This is my personal opinion. You know, there are experiments when I would trust the temperature determination more than in other experiments, but I can name experiments in which I'm positive that we measure the temperature with an error of, say, hundreds degrees, 500 degrees Kelvin, and we claim to have an uncertainty of plus minus 150 that seems to move on from one publication to another.
Okay, sounds good. So basically, we should work on the thermal pressure and PT condition determination more precisely.
Exactly.
Yeah, sounds good.
Yeah, and always the gray body assumption, whether it's really valid for all the materials, that's the. Oh, there's Ben and Dan. I think Ben, you can go, maybe go first.
Yeah, I just have probably a question about about the laser spectroscopy, like the laser ultrasonic setup at the GCCARS. So I am wondering if there's any plan for it to be moved online so that you can do both X-ray diffraction and also laser ultrasonic measurements. Yeah, I know not many people are using the laser ultrasonic system right now. I think
yeah, it should be very good additional. And again, if you have available funds and manpower, we can do everything that you want. But there should be some priorities. So that's why we are holding workshop to define priority where should we move.
Go ahead, Dan.
Can I speak? Hello, can you hear me?
Yes, we can.
So I like to reiterate Sergey's really important point. You know, if I need to pick one or two that actually makes you wake up during the night for my experiment, is temperature measurement and pressure measurement. And we've been dealing this issue for many, many decades. But I also want to point out that the Compress have done a really great job of making sure that this development continues in the background. And education and outreach infrastructure and development committee has played very important role. And I hope that the new organization continues that tradition and support this fundamental, aspects of an experiment calibration. So I really want to emphasize the importance of that support, and also, that gray body, assumptions just for the shameless advertisement of our work. So we have recently done a large volume press and the laser heated diamond cell experiment together for triple point of MgSiO3. And we find disturbing pressure discrepancy of 2 GPa that is pretty well known between multi-ambule and the diamond ambule cell at about 24 GPa. But the good news we found is the temperature of triple point we measure in multi-ambule matches beautifully with laser heated diamond cell. That doesn't mean that that our method of measuring temperature will be safe for any pressure range. It just means that at least at the transition zone, at least for low iron content sample, it may be fine. but we need to continue this effort. And I think that the role of, I cannot emphasize more about role of this new organization for this fundamental activity.
Yeah, that makes a lot of sense. Thanks, Dan. Claire.
I was just wondering about any future prospect of laser heating while collecting single crystal diffraction at beamlines like 1390B.
Yes, we are doing it. So there are two ways. One of them is to use round tables that was designed at the by road by Leonid and Natalia Dubransky. And actually it works pretty well. There are some technical difficulties. And right now we're extensively developing at BMC. And Dongzhou was talking yesterday about this. Oh, Dongzhou, Przemek was mentioned about it. So there are ways to do. Yeah, there are some
Great
input
news.
from users need. You have to buy it, but it's working progress. So we're doing it.
Awesome.
Yeah. Dongzhou want to talk.
Yeah, so just to add to Vitaly's comments, yeah, so at BMC, we have been actively trying to make the laser heated single crystal work happen. It's still in the stage of commissioning at this moment, but I think we are making great progress. And we still have some issues like accurate temperature determination, because currently we don't have very reliable calibration lamp, and we don't have very reliable optical enclosure for the black body radiation calibration at BMC. But I think we are moving toward that direction. So I'm expecting in the next year, probably we will have some resource for the general users to explore this kind of technique. Yeah, it do require some additional effort to load a good sample. We are currently still playing with actually modifying the system very extensively, even at this moment. But I think my expectation.
It's fine, but what we
Yeah.
can get if the users will come with a round table diamond, so we can try to do it more, and not only at BMC, at IDD and.
Sure. Yeah. So
yeah.
IDD is definitely also another good place for this kind of technique. So yeah, I think we are making progress about this.
It's a work in progress. Yeah, it's fine.
So I think we have to end soon, but I just want to kind of give a recap, because I think that what just came up was really important, right? The idea that the proposal not only focus on existing and new capabilities and new techniques, but also focus on the foundations, right? The temperature measurements, the pressure measurements, and the techniques that we already have, making them as precise and as good as we can. So it's kind of this like two-pronged approach, really, as opposed to just always looking to the future to, you know, smaller beam size or whatever. And so I think that's a really important point. So thank you for all those comments.